let's look at some combining polynomials and how we do operations with those polynomials as functions. So we have two functions drawn here on this graph, and we're going to try to notate some things based upon this graph. First thing we need to do is we need to write down the values from the graph. Okay, well, I'm going to analyze my graph and put them into this table. Okay, so at about negative, I'm going to have to overlap this a little bit. That's okay. So at about negative 2, looks like f of x is about, well, this is f of x, and this is g of x. So f of x is about negative 2, it's about 1, 2, 3, 4. Then a negative 1, it's about 0. At 0, it's about negative 2. At 1, it's about negative 2. At 2, it's about 0. At 3, it's about 4. And then, let's look at g of x. g of x, at negative 2, it is negative 4. At negative 1, it's at negative 3. At 0, it's negative 2. At 1, it's at negative 1. At 2, it's at 0. 3, it's at 1. Okay? Now we're going to use our table and combine the functions, and then we'll use our table to create the graph. Let's do some combination. So 4 plus negative 4 is 0. 0 plus negative 3 is negative 3. Negative 2 plus negative 2 is negative 4. Negative 2 plus negative 1 is negative 3. 0 plus 0 is 0. 4 plus 1 is 5. This one's asking us to subtract. So we're going to do f of x minus g of x. Well, 4 minus a minus 4 is actually 8. 0 minus a minus 3 is actually 3. Minus 2 minus a minus cancels out to 0. Minus 2 minus a minus makes it negative 1. 0 minus 0 is just 0. 4 minus 1 is 3. Now we're going to multiply. 4 times negative 4, negative 16. 0 times negative 3 is 0. Negative 2 times negative 2 is 4. Negative 2 times negative 1 is 2. 0 times 0 is 0. 4 times 1 is 4. Now it wants us to divide these functions. F of x divided by g of x. Well, 4 divided by negative 4 is negative 1. 0 divided by negative 3 is 0. Negative 2 divided by negative 2 is a positive 1. Negative 2 divided by negative 1 is a positive 2. 0 divided by 0 is, you can't divide it by 0. 4 divided by 1 is 4. So we've got some values for our table, which we are going to now take and put on our graph. We have to make sure that we clearly label our graph here. That way we don't get things confused. Okay? So, let's go ahead and plot some points. So for the combination of f of x plus g of x, it's negative 2 comma 0. Negative 1 comma negative 3. 0 comma negative 4. 1 comma negative 3. 2 comma 0. And then 3 comma 5. So it looks like a graph kind of is going to end up looking kind of like this. That would be our graph for f of x plus g of x. Again, this is a rough sketch based on our values. Now, let's try f of x minus g of x. So it's negative 2 goes up to 8. 1, 2, 3, 4, 5, 6, 7, 8. Negative 1 goes to 3. 0 goes to 0. 1 goes to negative 1. 2 goes to 0, and then 3 goes to 3. This looks like a graph kind of goes like this. Again, this is a rough sketch. It is not meant to be exact. But you kind of get the idea. All right, now let's graph the next one. Obviously, we can't graph that point, but we're going to graph the other one. So negative 1, comma 0, 0, comma 4, 1, comma 2, 2, comma 0, and then 3, comma 4. So now, with all these graphs here, I got to be very careful I don't accidentally connect something that isn't part of my graph. So let's look one more time. So it's negative 1, comma 0, 2, 0, 4, and then to 2, or to 1, 2, okay. And then that went down to 2, 0, which then goes up to 3, 4. So this graph we're going to label purple. So this one looks a little bit different than some of the other ones we have so far, and we'll talk about that in a second. All right. Again, these are rough sketches. Now, f of x divided by g of x goes negative 2, negative 1, negative 2, negative 1, negative 1, 0, 0, 1, 1, 2, then 3, 4. Okay, 3, 4. So it looks like if I connect my dots correctly, it's going to look kind of like this. Okay. And then we're going to go ahead and highlight with blue. And there we go. So we have several graphs going on here. We're going to talk about this in a second. But the idea is we multiplied and combined some numbers from one of our graphs to create new graphs. That's how we created this. Now we're going to try to analyze these graphs, see if we can create some equations. Okay? So one of these equations we should be able to make by ourselves. That's the equation for g of x. G of x is a linear function. We're looking at it, okay? So it looks like it reaches negative 2 is our y-intercept, and goes up 1 over 1. Be careful, this is not actually over 2, it's over 1 because these boxes are going by 2's. So it looks like it's actually 1x minus 2 is our equation there. So to get our function of f of x plus g of x, we're going to have to do some work because we have to multiply to get our new equation for f of x. Well, if we do our area model method, that will show us how to find the area as a sum rather than the product. Well, x times x is x squared. X times 1 is x. X times negative 2 is negative 2x. Negative 2 times 1 is negative 2. I have x squared plus x plus negative 2x minus 2. Combine my like terms, I get x squared minus x minus 2. So our equation can be written as x squared minus x minus 2. So to find f of x plus g of x, we are going to add, well, x squared minus x minus 2 plus 1x minus 2 equals x squared, 1x minus x is 0, then it's just x squared minus 2. Okay? F of x minus g of x means that we have to be very careful with our signs because I'm subtracting the entire thing, which means that this is going to become opposite signs because it's really a negative 1 to be understood there, times all that, which then gives us x squared minus 2x, and that's it. X squared minus 2x, because this becomes negative 2 and a positive 2 is 0. Now the tricky part is going to be multiplication, which we're going to try to multiply these functions. And for that, we're going to write it out. Okay? So it is x squared minus x minus 2 times x minus 2. We have it as a product but we do not have it as a sum. That's what we're going to try to find. Very important you take the time to go through these steps because you don't want to make simple mistakes. X times x squared is x cubed. X times negative x is negative x squared. X times negative 2 is negative 2x. Negative 2 times x squared is negative 2x squared. Negative 2 times negative x is 2x. Negative 2 times negative 2 is a positive 4. We're going to combine like terms. X cubed minus 2x squared minus x squared plus 2x minus 2x plus 4. These will reduce, and I'm left with x cubed minus 3x squared plus 4. So it's x cubed minus 3x squared plus 4. That is how we multiply. Now let's do division. If we divide, okay, we're getting into a little bit of higher level stuff, but I really want you to see this. So I'm going to take my original form. I'm going to divide it by x minus 2. Okay, that's the division that's going on here. I'm doing x plus 1, x minus 2, x minus 2. It's division. Well, what happens? Well, if we're thinking about it as a fraction, well, this is removed because it reduces to just x plus 1. And that's kind of how we got our graph here, right? Because it starts at positive 1 as a y-intercept, and it goes up 1 over 1. Again, this is 2 blocks, which really going every 2 is 1. So going up 1 over 1. But when we were looking at our table, something weird happened, didn't it? That's right. If we look at our table, something happened here. Why do you think that this 2 caused a problem? Why? Well, it should be, we should have gotten what number? If I plug in 2, 2 plus 1 should have been 3. Shouldn't we gotten a 3 here? Well, the issue is when we divided the function, we ended up in our original function, we had an x minus 2 here. And if I had plugged in 2, what would have happened? We would have gotten 0, and we can never divide by 0. That's why this part right here didn't work. Again, that's an advanced level question. but just to give you an idea as to why that's like that, and just so you're aware for the future. Okay, now let's analyze the x-intercepts and the shapes. Well, the x-intercept here on our f of x is just -1, 0, and then 2, 0. For g of x, our x-intercept is 2, 0. Okay, we're doing estimates based on what I can see on the graph. The y-intercept for our, wait a minute, no, I'm correct. The y-intercept for g of x and for f of x is actually the same. It's 0, -2, 0, -2. And our shape for this one is a quadratic or parabola, and this is a linear function. Okay? Let's look at the other ones. So for f of x plus g of x was our yellow graph. Our x-intercepts looks like they are -2, 0, and then 2, 0. Our y-intercept is 0, -4. Okay? And, whoops, I made a mistake over there. -2 is a -4. And the shape is a quadratic. Okay? Quadratic. Now for here, our x-intercept for the pink graph is a little bit rough. Okay, so we're going to try to estimate the best we can. We definitely won't be exact, but we can be close enough. So the x-intercept is about 0.25, 0, and maybe about 1.75, maybe 0. And then our y-intercept is again about maybe 0.25. But our shape is definitely clearly a quadratic. We're going to talk about why we know these are quadratics in a second. Okay, for a cubic, all right, there was a clear intersection of the x-intercept on the x-axis at -1, 0, and about, if I had drawn this correctly, it would have been 2, 0. Okay, and our y-intercept is at 4, +4. And the shape is a cubic. We're going to talk about why it's a cubic in just a moment. And the last one is the blue line. It goes in a straight line. It's definitely linear. Okay, the y-intercept is 0, 1. Our x-intercept is -1, 0. And there we have it. So now the question is, why are these the shapes that they are? Well, when I multiply two linear type functions together, I change the exponent to a square. That's what makes it quadratic. Here, it was just linear, and we can tell because there is only a 1 on the exponent on our x. Here, for when we combine a quadratic with a linear, we didn't get rid of our exponent on the x with the second power, so it stayed a quadratic. That didn't change. And here, when we subtracted, we never got rid of our exponent of 2, so it stayed a quadratic here. Now here's where it got different. We had an exponent, the highest exponent here was 2. The highest exponent here was 1. When we multiplied, the highest exponent wasn't 2 anymore. It became 3. That's what made it a cubic, having that exponent to the third power. Over here, when we took a quadratic with the power of 2 from up here and divided it by a linear function, the power reduced from a 2 to a 1. That's what made that quadratic into a linear function. So we analyze the shapes just based upon the exponent of our function. It's about the exponent. Well, there you have it. We have analyzed, we have created graph from some tables and some graphs, and then we analyze how we get the equations and how to analyze some different pieces about it. And that's it. That is combining functions. When we're combining these functions, it's really important to pay attention to the y values. That's what we're really working with when we're trying to create these tables that we just were with the previous graphs. It's also very important you pay attention to the signs and how the signs interact and how the signs affect each other. That's where you're going to make mistakes, so you have to be very precise and pay attention to the details.